Welcome, everybody. We'll get started in 2 minutes. The other session is wrapping up, so people will start coming into the Industrial IoT Security Maturity Model session. So thanks for joining. We'll get started in a couple of minutes. If you just joined the room, you will be placed in silence mode. However, feel free to interact and post your question. The session is live, so we're going to have a section for the Q&A moderated by Don Malloy, so just wait for that. We will record a session and we'll make that available on demand. So if you do not wish to participate in a recorded session, this may be a good place to part way, but we plan to record this and make it available. And let's make it as interactive as we can. So leverage the Q&A. If you feel that you're getting, there's too many questions there, take this conversation to the Twitter and LinkedIn. My team will be following the subject matter experts to make sure you get answers. So leverage the hashtag IoT World Day. And on that note, I want to take this opportunity to thank you for joining, thank the speakers for supporting this event as part of the October Global Awareness Cybersecurity Month. I'm Lucian Fogoros. I'm one of the co-founders of IoT World, and I look forward to hosting you. I also want to take this opportunity to thank our sponsors, Adolos, RunSafe Security, Temper, Trend Micro, Archer Security, and Building Cybersecurity for supporting this event. And at this point, we'll get started in a minute. It will be just getting the short music, and we'll get started in a minute. Welcome everybody. I'm Lucian Fogoros, and I want to transfer over the command to Don Malloy, who will moderate these sessions. Thank you for joining. Don, the floor is yours, and you got full control of the screen.
All right, wonderful. Thank you, Lucian. Well, welcome everyone. Good afternoon, morning, evening, wherever you might be. We're glad that you have joined us, and the ones that are just coming in, come on in, sit down, grab a cup of coffee or tea, whatever you like, and listen up. We got some good stuff for you today. Myself, I'm Don Malloy, and I am the Director of Business Development for a company, authentication company called DualAuth. And I'm also the Chairman of Oath, the Initiative for Open Authentication that wrote the algorithms a number of years ago for multi-factor authentication, which is pretty much standard in the industry. It's open source, and it's what everybody uses. You use Google Authenticator, use Computer Associates, your bank sends you a one-time password token. That's usually the Oath algorithm, pretty much. And so today we have a number of great panelists, and we're going to go through them. We're going to see a little bit of talk from each one of them, and then we're going to open it up. We've got a bunch of discussion questions that's going to be exciting, and I welcome you to go into the little control in the bottom of your screen where it's Q&A. Put in a little question if you want to have it answered. So with that, I'm going to move on. First speaker we're going to have is Leon Gerard Vandenberg, who is going to show you a couple things. And I'm not going to give the bios. I'm going to let each one of them give a little bio on themselves, since I think they know themselves better than I do. So we'll start with Leon, and go ahead. The floor is yours, Leon. You can unmute and just start up, and I will show you what Leon has to say. Let's see. First, I'll get the slides going.
There we go. So Don, we have known each other for almost 2 decades, I think. So you do know a little bit about the background, what we've been doing. So with our learnings, my background is systems engineering, a little bit of defense tech. With this company out of Australia, we created some of the first e-money systems for US Treasury called US Navy Cash. And that system was used to replace all the cash and coin on Navy ships. Of course, with defense, there's no adoption problem. So, you know, just like on Star Trek, the captain says, make it so, and it all happens. So we had no problems with our technology stack being adopted. It was rolled out through the whole world, through the Pacific Fleet, Atlantic Fleet. And the security doctrine that we did was really around smart card, POS security, and into these early models for controlling devices at the edge. In my background, I got involved with carbon trading and some smart energy projects about 10 years ago. And we got involved with blockchain and Bitcoin services. And what we've done is taken some of that learning from those two industry paradigms and put this into a sensor network that goes onto solar farms. And these sensors are really deployed per panel on each solar panel on a solar farm installation. And that's really what is our company, Sonified. And I would really like to talk about the IoT security, this kind of model where we're going from just being sensors for data acquisition for SCADA, but now getting into more of the machine learning and predicting your response. So that's really my discussion today. Thanks.
Okay, I neglected to show your slides, Leon. So there's the first. You want to talk about your slide? Oh, we'll hold that and we'll go back to that. Or
no, we could just start here. So what Sonified does is really provide four things at once. We provide some problem solving around energy provenance, so we can track the electrons as they're produced on the actual panels themselves. There is a problem with greenwashing in the industry. There's even carbon credit fraud and carbon fraud in the industry. On the DC side of the network, where the energy is generated, there is a lack of transparency, what is actually happening on the network. And once it's in the field, there's also faults finding is hard to do. There's a problem if you want machine learning, you need to find very high data quality and good interval data, and that does not exist in this industry at all. And we also do some work around providing this blockchain authentication and also turning each solar panel into a fractional asset that can be put into a crypto model. And this crypto asset becomes something that's very green and ethical, something that anyone in the world can own and share. And of course, when the sun comes up, everyone who owns a token makes a little bit of money. So it's a good feeling type of system as well. If you want to tab forward one more, Don. We solve this energy provenance around this proof of origin. Each panel reports its proof every 30 seconds, and we make that a crypto proof, not just a data acquisition signal. It's actually a crypto proof along with the temperature of the panel. If we're going to forecast a panel, we need to really know its local temperature, and that goes directly to the efficiency of the panel. With this panel level monitoring, we can also track more predictively these analytical events for machine learning around predictive failures, or if a panel was installed improperly, or if there may be a warranty fail in return. And again, leveraging on this high granular data, we can start to build machine learning models. Eventually, after a year, we would see the seasonality to be programmed out of the project. So then we can start to do forecasts and artificial intelligence on bidding or trading of energy and maybe even energy futures. So this all goes to the storyline of trying to create easier ways to finance a solar project without having to cram down the solar farm owner operator into a low price power purchase agreement. The solar farm owner operator can bid into the spot market if they know what is going to be the yield off the park for the next 2 hours, for the next hour. So we really do leverage this data in a real-time way. And if we go a little bit further, Don, on the next slide, what we're really going to be talking about is how we solve this other challenge on making it all work together. So in the industry, no one in the industry is doing what we do together on 4 value frames all at once. There are industry people that do put sensors on solar panels, but they don't provide this type of crypto proof and trust model. There are people that use a type of embedded smart meter, but again, it's not at the resolution that we're doing. So this type of comparison in the industry just sort of shows how we're doing all of these 4 things at once, providing a panel level monitoring, proof of origin, this high granular data that is immutable, can't be hacked, and again, leveraging on top the capability to do crowdfunding and liquidity services on the blockchain. Thank you.
Very nice, very nice. I have actually have Enphase system on my solar panels, so I can look
Oh,
at
that's
my
a good little system, yeah.
Yes, I look
Yep.
at my array all the time. I can look at it on my phone and see what's producing and how much we're doing. And I still have to pay SoCal Edison a whole bunch of money because we had a very hot summer.
Yeah.
So, yeah. Very nice. Thank you.
Okay.
Thank you, Leon. And next, we're going to hear from Francois Lee, who is the founder and CEO of IoT Beam.
Yes, I haven't known Don for 2 decades. I believe it's about a couple of years, so it's a little bit different than Leon. And I participated in one of your security symposiums, if I'm not mistaken, a couple of years ago.
Yep.
So I'm based in Silicon Valley. My company is located in Palo Alto. We are typical Silicon Valley startups. We decided to tackle a very narrow piece of the IoT security world, specifically the outer edge of the IoT networks, i.e. the sensors, actuators, endpoint devices that are capturing data. And a bunch of us from the company, we thought about the solutions. We got the solutions patented, so we got a patent out of that. And our solutions really is there to protect the data that's being captured by the sensors, the real-time data. We found out that there are very, very few companies that are tackling that problems. They're typically working on the core or the edge all the way to gateways. There are very, very few companies that we're aware of that are really tackling the problems of the tiny IoT sensors and endpoints. We believe that is a problem that's going to be very, very critical soon, because we're deploying billions of sensors everywhere, from solar panels to anywhere in a smart city, in a smart building, airports, etc. Every aspect of our lives will be somewhat connected, and typically you have sensors at the very end of that. What you'll find out is that most of those sensors are typically very low power, low complexity one, meaning they don't have a multi-core processors there. They're running on batteries. They're typically wirelessly connected. And for many of these reasons, they do not have a security embedded into them. And we believe that's important to protect the data. So if you could move to the next slide there, Don. What we found out that there are quite a few major challenges in trying to design the security solutions for low complexity, low power sensors and endpoints, and typically they revolve around the fact that these are very low cost. So cost is a major consideration. So you cannot really redesign them or add new security chips or better chips there. They're battery powered, which means that battery drain is a major issue. Apart from cost, they don't have a lot of memory, a lot of processing power. So the solutions that you have to design has to fit into those parameters, and basically that's not very easy to do that. And you cannot really use a security system coming from the IT world. Typically what companies do is that they monitor those sensors, detect anomalies and so on, but they're not really protecting the endpoints or the data. And the data these days are being fed into automated systems, some of them, AI, ML driven. And if you don't know that the data is very secure, you cannot trust the data, and And basically the decisions you're making may be just totally wrong if the data has been tampered. And that's what the problem that we are addressing at IoT.
Very good.
That's it on my side.
Thank you. And next we have Roland, and I believe it's Atui, if I pronounce that correct, Roland.
Yeah.
Roland.
Perfect.
It should be, right?
Roland or Roland.
Roland.
or Roland in German.
Yes. Yeah, from Red Alert Labs. And go ahead, flourish yours, Roland.
Thanks a lot, Don. Hello, everyone. So I'm indeed speaking to you right from Paris, France. So for those who do not know me, I'm expert in cybersecurity, has been working for the industry for the past 15 years or so, coming from the mostly smart card embedded world, so really the device side security, worked for companies such as Gemalto, earlier Oracle, where I discovered mostly the IoT world, and I'm right now heading the Red Alert Labs since 2017. So I'm as well participating very much in standards organizations actively on the IoT areas, cybersecurity, on the European level with the European agency ENISA for cybersecurity, as well actually on organizations such as the FIDO Alliance, addressing, by the way, authentication, where I usually meet Don. And that's basically what I come from. I've been working for the past almost 8 years specifically on IoT, so to address exactly the challenges, and that's where Red Alert Labs actually initiatives came from, and I'm the co-founder, is to basically address those challenges that are brought by this new infrastructure IoT that's should be addressed, taking into account both the technical perspective, but as well the commercial perspective, right? So Red Alert Labs is there to bring trust to the Internet of Things, in the sense where those manufacturers of those devices would like to express that level of security, would like to give that claims, and actually they need to provide that trust to the ecosystem, to the buyers, and the other way around, actually the buyers, the users, integrators would of course definitely first would like to understand what their needs, and then have trust in the systems and the devices that are using and they are connecting in their ecosystem. So we do that by providing mostly part of consulting services, frameworks. This is exactly where we usually apply the industrial IoT security model to bring that business needs expressed and actually bringing the requirements. And then we act as a lab. So we have lab capacities to assess actually this security from the device up to the cloud, so from chip to cloud, specifically using methodologies dedicated to IoT, and that's really the innovative approach that we have, is that we tackle the IoT in a horizontal approach, and then depending on the vertical's needs, we create profiles, basically those that usually are described in as well the Industrial Consortium model, security model, to be able to exactly address the security level of assurance that is required with the right assessment methods, the right techniques, and of course we are not here just to deliver certification, but as well to help in building that level of maturity in the organizations. On the last aspect that we address is, as you know, IoT is bringing new challenges. lacking of expertise in those companies that are creating the devices and companies that are integrating. They're very hard to quantify the risks of those new ecosystems. There are time to market challenges. There are cost challenges. So all that actually required somehow to discover, or let's say to innovate and to bring in some tools, automated tools, to sort of build in the security by design in the most efficient and quick, cost-efficient way. Right, so that's where we bring in R&D here platforms, softwares that would help each stakeholder, from really the business business line, the risk owner, down to the developer itself, to be able to address exactly the need by specific requirements, guiding these through, of course, applying existing standards and bringing those to the level of maturity where they are able, for example, to certify in such platforms, to be able to bring that level of trust to the ecosystem. So that's what we tackled today, and I think we mostly actually could. Today, actually, we act from France, but we already actually has presence in the US, in Asia, and yeah, and so that's basically it.
Yeah, very good. Thank you, Roland. And next we have we're going to hear from Vikram Sharma, who's an engineering manager at Cisco. And with that, I'll turn it on over to Vikram. Tell us a little bit about yourself and what you want to talk about.
Thanks, Don. So first of all, welcome to this panel. And for those of you who don't know me, I've been part of Cisco for almost 20 years. And for the last about 18 and a half years, I've been part of Cisco manufacturing. My responsibilities was building, deploying, and then maintaining IoT quality management systems across our factories and our partners and our extended supply chain. My training is electronics, and then my postgrad was cryptography and computer science. So I turned up here in this space to try and protect intellectual property as Cisco was going in an outsourced production, an outsourced supply chain manner. So I've seen, the challenges we've faced when you deploy a IoT system in a manufacturing, in a distributed manufacturing space, and what are the attacks that are mounted, both the standard, malware and intrusion attacks, as well as data, critical data attacks, so I've enjoyed this field, and since about a year or so, I've been part of the IoT business unit in Cisco, where we manufacture a lot of the networking devices and gear suitable for the industrial IoT space. And I'm trying to drive the solution architectures for industrial security. Pretty exciting. I have a couple of slides as talking points. So Don, if you could please advance, kind of to look at, what are the problems and challenges we've seen. All of us have read so many news reports of, different companies being taken out because of a breach, an industrial breach. But essentially, we've boiled it down to top 4 items. These are sort of the roadblocks towards creating and securing an industrial network. There's lack of visibility. Malware somehow creeps in so many different ways. And then IT and OT need to improve their workflows so they can leverage each other's knowledge and strengths, the complexity. So the maturity model that we've been looking at, I've been focusing here on, is how do we what kind of guidance will get the customers towards a fully converged and secure industrial system. So we basically said, let's break the journey down into 3 steps. And these steps we're calling minimal security, foundation, and full spectrum security. And each of them are backed with architectures and implementation guides. And what happens in this is you are limiting your objectives. In step 1, you expand your objectives, and then you have a full-fledged system.
Oops.
And it sort of helps reduce the complexity. If Don, if you may, please
I'm sorry.
go back a couple of slides.
Yeah,
Thank you.
Things went haywire here.
No worries. So the goal for this journey, one step back, please, is to not only to deploy technologies, but also to upskill the workforce, right? So as you learn how to take care of your systems, you can do better job on security, as well as the workflows within the organizations. And just a quick blip on the next slide, please, is to give you a feel for the maturity model. If you think of minimal security, it consists of one product. It establishes some security in your connectivity. We are basically saying put a DMZ between your enterprise and your industrial network. Then you move on forward to foundational security. And the foundational security adds 3 products. So all of these are additive. You're getting more and more sophisticated in your protections. You add just 3 more products, and it protects you against malware. It establishes an integrated operations, security operations center. So it enables your IT folks, your InfoSec folks, to provide security cover onto the industrial side. Today, we find that lacking in a lot of installations. And then you move on to full spectrum security that lets you deepen that security cover and control. And I've listed some of Cisco's products that kind of go in here. The goal is not to dive into these, but sort of to give you an idea that the maturity model tracks the technology. It enhances your security posture, but you need to track your skills and your operational processes in order to move on that journey effectively. Mm-hmm. And lastly, I'll just kind of end with, on the last slide, is, the key takeaways: build a DMZ, then establish this workflow between IT and OT, and then you operationalize industrial network security, i.e., let's have us, the manufacturing guys, the OT folks, look at security as another maintenance process. This is what you do. You need to oil your gears. You need to upgrade your firmwares. You need to patch certain things, right? So we established the foundation. To us, the security foundation is key. And then you move on forward to more sophisticated security postures. So that's the kind of work and research I've been doing over the last few years based on my experience in running Cisco's manufacturing plants and our experience thereof. So I'm happy to be here and looking forward to the conversation.
Very good. Thank you, Vikram. So as the title says, this is a security maturity model, and I think that was a great lead-in, Vikram, with the way you talked with the 3 mountains, the little hill, the medium hill, and then the full scale. And when I look at that, I see a number of models that are out there, right? I mean, I happen to like the Lockheed cyber kill chain. There's another, 5-step model of doing, identifying your assets and protecting them, and then detecting and responding and recover, and and there's so many of these steps about securing, defend, contain, manage, anticipate. And so let's get into some conversations about that. There is a question coming up here. So we have first question from Rashid is like, what are the key steps to optimize security operations in an IoT world? And I'll kind of throw that out to the panelists and see who would like to attack that to start with.
I can start
Okay.
One of the things what we've seen is you need to be able to get some level of visibility in what you're trying to secure. So deploying capabilities that let you see your assets and vulnerabilities of your assets, that's like step one. I would say step 1A would be get the team together. Who are you going to rely on? What's the InfoSec? What is the IT component? As operations, it's hard to really do these things.
Mhm.
So that would be our number 2. Let's get some mind share. Let's take up small pieces. And number 3 is run some practice drills, right?
Okay.
Secure a few things, try and run your workflows, and then expand.
Okay. Very good. And I think we have a question that is, as you know, industrial companies and environments, they're facing huge challenges, right? Every time they enhance their activities, everybody's trying to digitize everything, and connectivity is improving tremendously. So where should they start, right? How could they keep up with the state-of-the-art attacks and prevent the worst? I mean, that's something that's, I know everybody's trying to handle that, and how do they do that? Who's, you know, Roland or
Yeah,
Leon?
I can.
Who wants to jump
Sure, I
in?
can take it. So it's very interesting question, right? So it's bring us really to the main topic that is addressed today by you know, the IoT security maturity model. So the first things to do is really start from this business needs, right? To understand exactly what are we today. What do we need to, why do we need actually to secure, and what area should we prioritize, for example, to start with. So this is really a main challenge today, because translating those business needs into really practices and actions is not really a simple thing to do, right? So I would recommend that really to this to apply, for example, first steps, simply the steps that are described in the IIC industrial security model, to start with, for example, bringing in on actually those stakeholders, business stakeholders around the table, and discussing what are their challenges, because they could really could be very high level. And could be simply, I just want to be to avoid being hacked, like my competitor has been hacked, for instance. So it could start actually at this level, right? It could be more an awareness session, and then go down actually to define the steps of what we call actually the target, the maturity target. So here, you will try to imagine, or let's say, bring on the level of maturity they would like to aim at, to be able to then actually assess exactly what you have already, what is the level of maturity that you have, and then identify the gaps. And finally, of course, take actions to close on these gaps, and reiterate, right? So that's one of the most agile, let's say, things that you can do to be able to, because actually, indeed, the state of the attacks, state of the art of the attacks is changing, and if you're not actually deploying such type of frameworks, you will have really big issues to deal with, and of course, you will there are costs for security. So if you are not able to prioritize and to tackle and put the effort, right, the areas where they are need to be dealt today, you will miss a lot of items, and actually the risk actually for having a cyber attack will be higher.
Absolutely. Good. Anybody want to add to that? Any thoughts we have that?
Yeah, Don, as I was listening to both Vikram and Roland, I kind of agree with the different steps that they are suggesting. So I like the model of the journey going through different, different milestones and so on. It is very typical in the world of industrial IoT to go through this journey. The security is not something that can be done in a single day or can be done immediately. What we found out is that it goes step by step. That during the transition, you see systems that have some security design into the systems, but you're still using older system, existing systems. You have also a number of protocols that are very specific to the industrial world that you don't see in let's say in the networking world, in the telco world, and then protocols like HART or Modbus, etc., which are MQTT, which are very, very specific to the IoT world. So bringing all of those systems, existing systems, new systems, the IT people, the OT people together, and so on, have them engage in the dialogue and trying to come up with a plan to bring more security into that transition, since we're talking about the transition of the industrial world to the new world, is not going to be easy, especially that you have a large number of IoT security vendors, so it's a little bit mind-boggling. You may need to bring some professionals or people on board to make sure that they select the right solutions. So all of that is part of the equation there, Don.
Yeah, I agree. I wonder.
And I
how
might
many...
pipe in and
please
just use our solar industry as a vertical application, because Vikram and Roland are really talking about a horizontal kind of architecture across the whole industry. We really said, okay, if we're going to do this right, we want to pick one particular vertical and do it the best we can. So that's really been our doctrine, to say, where's some place that has some sore points, where can we fix those? Where is going to be an installation where there's going to be a really compelling need to do this at a greenfield site? It's very hard to retrofit sensors on existing things, to retrofit cybersecurity or to retrofit any type of these models is very hard. So we're really taking a plan to strategically build out 30 virgin new solar farms with our infrastructure built inside, so that we are eating our own dog food, so to make our own case study to showcase this availability. And to be able to do this from first principles, to show how the data is used when the plant is being built, when the plant is commissioned, through its kind of running phases as it goes through its life cycle. Through the first couple of years, there's a kind of run-in period. And each industry has to have their own little maturity model, because if we just use this kind of case study, you can imagine in an industrial plant for petroleum, there may be a different type of life cycle, infrastructure upgrades where you would have those opportunities to refit and do those sensors, where you can't really do it on a live bit of kit, right? This is hard to do and hard to get buy-in, especially on the control interfaces. We also said, we're not going to try and do control first. We're just going to do data acquisition. Just go get as much data as we can and get high quality immutable data. And then later on, we'll work on the integration into the SCADA control, because that is a more difficult thing. There's regulations and also acronym soup. There's a convergence between IEEE and what's happening with Energy Web Foundation, SunSpec. And so these whole industries are going through a whole life cycle of realization that the prior standards are not fit for purpose. There's conflicting standards between different countries and regions. So we're trying to provide a mechanism to allow this fintech fabric to also be used as an IoT cybersecurity upgrade as well. And we've really said the only way to do this is not to try to do everything all at once, is to be really focused on this one industry category.
Absolutely.
Sorry?
That's great. Coming from a person that believes in edge security, I think having it all the way out into the sensors and having your sensors secured all the way back, into the network is so important. And I agree with that.
And just to resonate what Francois and Leon were talking about, every industry has to kind of figure out, where they're at, or every company for that matter. And the brownfield, your equipment is going to be of so many different ages.
Yes.
In manufacturing, we try and use capital equipment down to the last cent if possible and more. So there are long lifetimes you have to live with. And what Francois mentioned is very, very pertinent. You have to figure out how old equipment and brand new equipment, how you can provide some level of consistency across those. That becomes an increasingly important item. And one thing I would like to add to the question was, there are so many problems, and I think Leon kind of mentioned about it in the security world. If you basically try and say that I'm going to secure everything, it is very hard. It's like boiling the ocean. What Leon mentioned kind of resonates with me. Let's pick one problem, right? Hopefully you pick a problem that's more relevant in your space, in your industry. And let's try and solve that one problem, right? And that one problem, of building a security posture to protect against that one threat, and pulling in the stakeholders, be it your IT folks, your InfoSec folks, your OT folks, getting that ball rolling, so as to speak, you will learn a lot, and then you will be better able to handle 3 problems after that. So, to respond to that question is pick one first.
Very good. I like that. So there's another question from the attendees. This one says, brownfield remediation of legacy stuff, is that something that needs to be considered? And if this is true, what are some of the areas and common problem areas that typically need to be addressed to advance the IoT security into an industrial environment?
If it's okay, I can open with my thoughts.
Sure.
I was just thinking about the brownfield and the question popped up.
You started talking about brownfield, so it seemed like it was appropriate. Yeah.
Yeah. So, what I'd say is, I think it's Leonard who asked this question. What I'd basically say is, you have to consider brownfield and legacy, because you'll find that what we think is legacy from an IT standpoint, your OT guy is going to use it for another 10 years, right? So it's not legacy for your OT operator. And it adds to the bottom line to keep that capital running and operating. So the common problems is you can't patch those. You don't have the security protocols built in. It doesn't talk this way. It can't, once you open that legacy box, you'll find a whole list of items you have to battle against. One of the things that has helped, at least in my experience, is don't try and solve it. You cannot fix it. Just contain it, right? Just use, what's that old, the Gordian knot, Alexander's Gordian knot, right? Don't untie the knot, let's cut it, build a boundary around it, right? And contain it. So if you are able, I'm talking about an electronic boundary, a firewall, some port control, you can come up with different ways depending upon the area. But if you can't solve it, you must address it. At least let's try and contain the issue. That's what I would kind of like to say.
Okay. Anybody else?
And Don, just to add on what Vikram and in fact Leon were saying earlier, we're talking about brownfield, and I guess I'm the one who started bringing that to the attention of people, that in the industrial world, it takes time for the companies or the solutions to get to change or to evolve. When Leon said, or Vikram said, you have some equipment that's been there in the field for 10 years. I mean, that's absolutely true. The sensors are typically left in the field for 10, sometimes more, 15 years. And so there's a very different life cycle than in the IT world, where you're replacing the equipment every few years. We're also dealing with exotic protocols, as I mentioned before, and you have the solutions of containing that and establishing some ways of monitoring things and so on. We at IoT try to tackle the problem head on and try to come up with a solution that can apply both to existing sensors as well as new sensors. So it's something that could work on both. That again, all the aspects that I mentioned before was there, and it should work also with all kind of protocols. So that the same security model can be applied across the board, from existing systems to new systems. Not going to be easy. That's why we are in business. But that's something that the industry is aware of, and let's say that's one of the things that we're doing. And we're just doing that small piece of the IoT security world. Vikram and Roland are more horizontal, as Leon said, and Leon is more on a vertically oriented type of industry. In our case, we're talking about a piece of the whole IoT security system that is the outer edge, beyond, as we call it, beyond the edge, or beyond the last gateways, the piece of the network that very few people pay attention to, and that's the one that we decided to tackle. So again, it is a possibility to retrofit security into systems that are already out there in the field, if the security solutions have been thought about that, well thought, and designed to address that problem.
Well, you had a thought?
Sorry?
Yes.
Oh,
Yeah.
it looked like you had a thought you wanted to share, Roland.
Yeah, definitely. I mean, it's just to jump in to add the fact that definitely should consider it, the brownfield remediation, and more specifically, you have to give some, put some efforts to analyze the risks. Okay, so really include it in your risk analysis. Okay, understand exactly what are the risks, and if actually you're finally able to get a grasp on what are the real risks, then definitely you can, take the measures. If you can contain it, if you can actually do other things, if you can improve the architecture to limit that risk of cybersecurity attacks, that's actually the right way to do it, right? So it's always a balance, because definitely that you have to find somehow a balance to be able to contain, to continue the operation. But then how do you judge on what exactly the remediation action that you should take? It really depends on that part of field, how it's actually employed, and how, of course, your strategy, especially when you are getting into more connected environments, connecting all your architecture, getting into the what we call the industry 4.0, some maybe in your strategy, you will definitely have to take progressive actions to start limiting the risk, and later on hopefully eliminate as much as possible that one.
Okay, sounds good. We did get a comment from one of the attendees that said Paul Parkinson said that the technology does exist to retrofit the same level of security into a brownfield device as well as a greenfield. And I think, Leon, you hit the nail on the head when you said, yeah, price points, because you could do most anything you want if the price is right.
Yeah, that's an interesting point.
We looked at that the same. Yeah. Sorry, Vikram.
Go ahead, Leon.
Yeah, we looked at the same, at the potential to do retrofits. And right now, the solar industry is advancing so quickly, and the learning curve on solar panel production, the cost per watt is still jumping down. Much like Moore's law, it's called Swanson's law.
Yeah.
So by the time you have something in and commissioned and it's up and running, if you are going to retrofit or do something, you could almost install brand new panels and get double the capacity than in about 4 years time. So,
Wow.
so it really is, you know, something to go out and do right the first time, to do that kind of best of breed approach. We think that the solar industry is really compelling for us to do it that way, and we don't have to worry too much with too many things moving once it's been installed. The reason why we also pick solar, it's solid state. There's no moving parts, and you know it should work for a good 25 years once it's commissioned right. We are worried about quantum and some quantum attacks later on, and we do want to find a way that we can be post-quantum ready. And I think that's a harder thing to try and fix, even from today's framework. So there's still some difficult things to be prepared for. But I think we're quite comfortable with where we are. But the whole industry is really challenged by this, having to get the yield off capital assets that are old, and having the right discipline to engage with the right life cycle models to you know, to make buyer partner, to find a right way to make them secure or quarantine and you know, firewall them away. So I think Vikram has a good handle on it.
Yeah, good point, Leon. Just to add to my thought, I think if there is a remediation, you know, to retrofit a brownfield technology, it should be evaluated, because quite often that will get you. It's much more easier in the long run. So case by case, you must evaluate it. And there are options. Sometimes the commercial aspects of that retrofit go against just the technology capability. And, you know, one example is you have a chip shooter that's been built in, you know, 2005 by, let's say, Fujitsu. It's operating well. You want to upgrade its firmware so it has more security protocols built in, but you know you're not going to be able to get support from the manufacturer. And although there is a package that you can deploy, so some units would make the decision: let us upgrade. We need the security because we are facing this threat, or the risk appetite is low. Whereas some units would make the decision: we will contain it, we will quarantine it, but we need the support from the manufacturer for this machine vendor. So to Paul's question, yes, I think there are lots of retrofits. We should evaluate it. In the long run, it is much easier to bring things up to the same level.
Okay. So there's a question here. This might, I don't know whether we'll all agree with this or not, and this is probably a good thing if we don't agree with it, because then it gives us a little bit more active discussion. But we're seeing that some industrial companies are complaining or reluctant in choosing IoT devices or suppliers. So what are the challenges they are facing, and what should they do to trust those suppliers? I mean, is that something that we're seeing, or is that something that we don't have to worry about?
Well, I can try to start answering. So it's a very interesting question, because I mean, it talks about this these challenges sometimes are that we see actually in the supply chain, and it's really they are real. They are real because if you ask all actually industrials actually today, depending on their, of course, maturity level, they potentially have some measures in place that somehow procurement requirements that potentially would help them choose or pick or let's say the right suppliers they trust and the devices that they potentially meet their requirements. It's not widely let's say adopted on IoT, because those actually requirements are not very clear. Standards potentially are are still, let's say, not completely adopted, especially in the industrial ecosystem, and therefore there is a bit lack of standards and objective requirement that allows every party actually to trust exactly, I mean, to use, let's say, the same types of measurements to trust or to evaluate, let's say, the devices before getting them, on board. There could be many of those as well suppliers that uses, if they don't use actually suppliers, they use sometimes open source, and that's another problem. It's as well a lack of trust, internal trust, because they don't really know exactly how these, for example, open source let's say parts components are being used, are being actually built in a secure way, how much actually their maturity is, and therefore it complicates a little bit the that assessment. So what we actually I would recommend here is to rely and start from the basics. There are some basic standards that are created today to address, let's say, the main basic requirements that should be, for example, available or implemented in any IoT device. We can think about the EN 303-645 ETSI requirements. We can think about 62443 requirements for let's say the first levels. We can think about other types of standards. It is a good way to integrate them in their procurement requirements processes, so they can at least try to assess those suppliers against something that is measurable somehow.
Everybody agree with that? Do we have any other dissenting opinions or other comments?
I think I would augment that. I would say there are three dimensions of trust from the industrial side. One is what Roland's been talking about, these standards that these products comply to, etc. The other one is the longevity of some of these IT products, these security products. Traditionally, these security products have been predominantly on the enterprise data center side, where the refresh cycles are pretty quick and frequent. On the industrial side, things last forever, right? So one question that keeps coming up is, will you support this 10 years later?
Right,
so
right.
you ask this question to an IT company and they go like, wait, what?
Yes.
Right. So that's the other dimension. And the third dimension is there is no single product that takes care of all your needs, right? You have to compose your security solution with a lot of different components. Some companies like mine have a fairly large portfolio, and some companies have purpose-built specific areas where they do a fantastic job. So in the end, a lot of manufacturers have to join these things together, and then it becomes, is it pragmatic to operate this system of so many different components in a optimal, in a way economic, that makes economic sense? So I've seen these three kind of come into play. The fourth dimension, I would not really categorize that from a trust standpoint. That is more internal. Can I stand up the team and the processes to really extract value out of all these thingamajiggies I'm putting together, right? So is it trust? I think it's a factor of all of this. And as we continue to focus our energies in the industrial space, we are attacking all these, I would say, areas of improvement. So I wouldn't say that there is a lack of trust. I think there is just genuine complexity that makes industrial operations, because the budgets are controlled by OT, right? The plant manager writes the check. It's the IT guy who has to do it. So there is that interlocked mindshare that needs to happen.
Sure, sure. And that trust is very important, and longevity. When we try and talk about the quantum safe technology, 5 years from now, that may become a pretty moot point, because things are going to change pretty rapidly when quantum computers come out with 200 qubits and whatever, 400, 500 qubits, and they'll be able to break any encryption that's out there. And we're going to need something really new. But the IoT side was on the security aspect. When I started up the symposium that Francois mentioned before, it was on IoT security. And I was focusing on initially on the consumer side. And then I started doing my work, and I started looking at it, and I said, consumer, nothing. No, it's the industrial side is where everything needs to happen. This is where it's important, where it's a power plant and things like that in manufacturing, not from a financial, certainly from a financial aspect, but also from a security aspect. That's critical. I mean, if somebody hacks into your Ring doorbell or your Nest thermostat, all right, that's your problem. That's not a worldwide issue. But if somebody hacks into the nuclear power plant down the street, we have some bigger things to deal with, right?
Yeah.
So that's it. And yeah, I think just on an off comment, but to Leon, one of the things I'm seeing in California is going to be probably wrestling with this pretty quickly. What do you do with the old solar panels? Because they're now some of them are reaching end of life, right? 20, 25 years. And the whole environmental reason for using a solar panel now becomes an environmental problem of what do you do with the waste?
They can all be recycled. So,
yes.
So in fact, it's urban mining, right? You can recycle those. They found ways to dematerialize the laminates into their component parts now. And but there is, even for solar panels, there's a secondary market. So you'll find that panels that are being pulled off in developed countries, they're being remarketed into India.
Just like 4-inch wafers is still being used somewhere, right? People are still buying 4-inch.
So are 3G networks, right? So
exactly.
The 3G networks are being put somewhere else, right? So the financiers will find a way to do that. So
yeah, there's always, you're right, there's always another way. So let's see, do we have any other new questions coming up here? What about so one of the things, Roland, you had started talking about this a lot, and it's something I always wonder about is the regulations, the international regulations, because Europe views the world very differently than the United States and some other countries do. I mean, you have when I worked for European companies and we were talking about product development, they would always ask me, Don, what's the 5-year plan? And I said, this is a startup company. They're just seed funding. They're trying to come up with a product. If it works, they're going to sell millions. If it doesn't work, the guy's going to move out of his garage and going to do something else. This is not a government-funded project that goes 8% great growth per year and stuff. But in Europe, so much of the innovation is predicated on government funding, right? Government funds industry, and then the industry goes out and develops it. And in the United States, that's unheard of, basically, right? But when you get into the regulations, now the government funds it, but they also want to regulate it. So in the IoT security world, I was at a conference years ago, and we were talking about the need for security, right? When the Mariah attack happened, and they hacked into all the cameras and stuff and everything, and took down Dyn, which is now Oracle, right? And a bunch of websites, and it became obvious to me that anything that's connected is a problem unless you put some real good security controls on it. And so we were talking about this in a conference, and they said, well, small companies in their rush to monetize their product, they want to get it out the door, and they want to get money, and they don't want to put security. This is when they start talking about putting in an aftermarket later on. And so we said, as an industry, we need to take control of this. We need to build the security in at the design stage, because if we don't, the government's going to come in and they're going to use their heavy hand and force the security upon us, which then nobody likes, right? We certainly in the US, we don't like to have government controlling us. We want to do our own thing from an industry
Well,
standpoint.
I don't think it'll be a very nuanced approach if they do come in. It's not going to be very elegant. So, you know, I think the industry has to find a way to navigate that. So
Absolutely.
yeah, it's
So I don't know if there was a question
is,
there, but yeah.
well, no,
Yeah.
it's a passion, right? John, you've been in it for a couple decades, so you've seen the progression, and you know, I think you give a different introspection on where things are and where they could be. Hopefully not
Sure.
in a dark, you know, Blade Runner future.
I view government control as sort of like going to the dentist, right? You go when you need it, right? I don't go to the dentist unless I really need it, or go to the doctor unless I have something broken that needs to be fixed. I don't just go there for the fun of it, right? And government regulation is kind of similar to that, right? They come down when they need to. But Europeans, I think, have been a little bit more accustomed to having a little bit more control of the future.
Right. So let me come back. Let's say to the main issue, or let's say mindset that probably gets actually Europe to set some regulations, maybe especially in cybersecurity, and take this actually more seriously. Well, in cybersecurity, that's I mean, especially in IoT, and then since we're getting more and more connected and more in complex environments with different types of suppliers that are involved, different types of service providers, operators, there's a lack of understanding of who's responsible, right? Who's when actually there is cybersecurity attack, who's responsible, right? And when you ask today this device manufacturer, he will tell you maybe it's something. Oh, actually, I'm using cloud service X, and that's actually securing my data, and I don't care. I have just set up a secure channel and so on and so forth, and then actually, you know, drop it probably on the operator side or on the service provider side, and the other way around. You ask each of these parties, and some of them, they don't really understand what are their responsibilities. So security today is driven by, like, I would say, like at least three areas, three aspects. So there's of course this marketing differentiator, right? So you want to put up security because you are selling it the value, you are better than the others. We start to seeing actually insurance, we start to see cyber risks talking a little bit, okay, getting like insurance to say, okay, well, I'm gonna pay if you had cyber attack, but prove me that you are mature in that security, so I can take that responsibility. And then you have the regulation magic that where actually in some fields, some technical domains, it's really had some impacts and really good ones, such as in the financial industry, right? Such as the ID market in Europe, passports, for example, biometrics, those areas that are more and more regulated are you know, are bringing a little bit of good sense to the industry, and increasing the level of cybersecurity in at least in this area. Well, Europe, for example, on the in 2019 set up a new regulation called the EU Cybersecurity Act, and that's basically gives like a sort of power for an agency, cybersecurity agency in Europe, that actually will and is working actually on setting certification frameworks for some of them horizontal, other verticals, and that's actually will like sort of become implementation acts and regulations that will drive the future of certifications in Europe, but at least in the upcoming few years till 2030 at least. And we're seeing, of course, IoT coming as a priority. the industrial as well. Automation is something that will come up potentially in 2022, 2023, potentially. That probably, of course, with some priority on specific verticals, will be regulated. And this actually becomes a mark that you have like a to meet a level of security assurance we call basic, substantial, or high, and some of the markets would require high, others would require substantial, and others would require like basics that potentially will be sufficient to get you that mark. So that's basically the status today. Things are going in this sense in Europe. It's not far in others, right? You've seen, I mean, in California, there's also a sort of regulation. It's still, let's say, and starting, right? It's not really very mature to set up specific requirements, certification schemes yet. In Singapore, we've seen lately on the consumer market some regulation that was, got out to certify or get the label for devices, and many others are following. Some countries in Europe already actually do impose, such as Finland, I guess, also a sort of certification label for IoT devices. Yeah, so you can see it either ways. It's like either a market access to single market or protecting the single market in Europe. It could be maybe for the good.
Sure. I think we probably have time for maybe one last question, and this might be one that give us a little bit something to talk about, was about distributed root of trust. What is it, and how do we see it affecting security versus not? You want to jump in there when we start talking about that? You know, when I look at like with
I posed the question, so
yeah, go ahead, Leon.
Yeah, I posed the question. So
yeah.
When you look at the electricity industry, the oracle of what happened on a network is always the smart meter or the sub meter, and different stakeholders in that industry have to take the smart meter feed as that gospel truth, and there's no real way to have an argument that something might have actually happened that's different. So in the energy generational side, there's always been a retailer and a customer, sort of a generator and a taker. And there's also some different legal mechanisms as to why would a distributed root of trust be interesting. And if we can take foundational measures, make sure that those measurements are calibrated, have a doctrine for proper maintenance of that plant and equipment, then those aggregated proofs of trust, they provide a higher fidelity of that whole data set. And in fact, in our mind, we're creating this kind of fintech fabric right on top of every solar panel, and we're allowing this kind of financial dial tone to be expressed in different digital instruments, not just the offtake of the energy, voltage or current, but actual yield and financial coupons. So this type of framework allows us to have a distributed consensus model for trust. And so if you just have one single actor, then there's always a chance that one actor could act bad. Or if you have a marketplace with only half a dozen actors, they'll just take turns gaming the market. Right. So what we're trying to do is to provide a more trustless way to provide that generation and to give it that objective truth. And that's ultimately what we're trying to do, is to give those little truth signals off the solar panel. We think it's very useful for our type of model, and it helps to build a new kind of financial paradigm as well on top. And it will be harder to deploy this kind of model in different types of plant and equipment or different other industrial types. But I could see the same thing happening in water or other critical resources where you have these commodity markets and derivative markets running on top as well. So there has been showcases of actors in these economies, you know, gaming the price signal and really damaging the marketplace because of that. They really have raped and pillaged, you know, the common man for energy pricing. And I think if you live through California, you've seen some of that.
We've watched it. I've watched it happen a few times. Yeah, it happened in 2010, and it happened again just recently. So we're wrapping up. We have about 2 minutes left, and I'd love to give each of you about 30 seconds of a cleanup if you want to start. Maybe we can start with Vikram at the top of the screen, and anything you want to.
All right.
Last words?
Excellent discussion, and you know, I would just kind of say that security adoption and increasing the security of your networks is actually not as complex as long as you're able to slice your goals into chewable parts. So start small and elegantly scale up.
I like that. It's Tom Peters coined the phrase that chunking. I always talked about, you know, how do you eat an elephant? One bite at a time, right?
One bite at a time.
Okay, Leon, you want to finish up?
Yeah, I just wanted to say thank you for everyone. I think it's a good introspection, you know, for the industry. We're really showcasing and focused on this kind of vertical in the solar industry. But to take a guideline from Vikram and Roland, you know, to take those baby steps and then create those incremental models with feedbacks. That's exactly what we're trying to do, and to eat our own dog food. So we want to help others go through this discovery tour and get their hands dirty with using sensors at the edge and cranking up their security model along the way.
Sounds great.
Thank you.
Thanks, Leon. Roland?
Yeah, I mean, they said it all. I would just repeat some of the really important aspect. First, thanks everyone actually for attending and for giving us the chance. We briefly discussed the importance of this IoT security maturity model. I really recommend you not to take it as indeed a horizontal approach, but really to tailor it to your needs, indeed to your verticals, to talk with your business lines if you are not the one who you're the risk owner, make this connection between those security experts and those business lines and decision makers, and really apply such frameworks. It's really the way forward to build up, start from scratch if you didn't start already, and build up actually your maturity as long actually that this is needed for bringing that trust or increasing that trust in security.
Sounds great. And Francois?
Last but not least, baby steps, absolutely, is a long journey. That's very true. Something that you also must have heard from the discussion is don't forget about your legacy systems that are still there. The longevity of equipment in the industrial world is much longer than in IT. Okay, that's what Vikram in fact stressed, that you have equipment that have been there for years, and they're gonna be there for many more years to come. And many of this equipment have been designed in a world where connectivity was very simple, just a wired and so on. They were not designed to be connected into a more automated, intelligent, AI-driven, ML-driven type of systems. That's where the security issue comes also. And as I said, don't forget about those systems. Try to bring them, retrofit them into your new world. It's okay to talk about new systems, new regulations, new designs where security is built into that, but don't forget about the other systems that are still there and will be there for quite some time.
Wonderful. And with that, I'd love to thank you, Vikram, Leon, Roland, Francois, and Lucien, and Carolina, and the rest of the team at the IoT World. We appreciate that, and we thank you for inviting us to come speak.
Thank you all for joining, and don't forget to join us on the last session with use cases for manufacturing and oil and gas. It's happening on the other channel. Appreciate your support for the Industrial Cybersecurity Day, as well as the support for the whole Global Awareness Cybersecurity Month. With that, see you in the next session. Thank you.
Thank you.
Thank you.
Thank you. Bye-bye. Ciao. Thanks, guys.
Bye-bye.